Okay, so this video is going to be a review of Unit 6 that covered momentum. This will also be a review for the type of problems and information that's going to be on our third 9 weeks exam. All right, so the first concept we talked about was momentum. You know, we define momentum as the product of the mass and velocity. That's what momentum depends on. In our equation, we used a P for momentum, and then mass is M times velocity. The units for momentum is kilograms times meters per second. Now, the thing about momentum, if you increase the mass, you increase the momentum. If you increase the velocity of an object, you increase its momentum. If you decrease the velocity, the momentum would go down. Now, another concept we talked about was impulse. We define that as the product of the force applied to an object and the time interval. Multiply those together. So the equation for impulse we use is I equals F times T. And the units for impulse are Newton seconds. Newtons times seconds. Now, a Newton second is equal to the same thing as a kilogram times meters per second. So, say newtons times seconds equals kilograms times meters per second. Those units are interchangeable. You could use either one of them with these problems. Now, the impulse momentum, and it's called the impulse momentum theorem, is how they relate to one another. We relate those together with an equation, and it's this one. Force times time, that's the equation for impulse. We set that equal to the momentum, the change in momentum, which is M VF minus VI. That's the equation we use for impulse momentum. We have problems where that's solved for one of these things as part of this equation. Now, another thing was the change in momentum. And what the change in momentum is, we used a delta, that stands for change in. Delta P, the change in momentum, is equal to mass, and then times final velocity minus initial velocity. Now, a lot of times these problems, it'll tell us if something starts at rest or something's coming to a stop. If something starts from rest, its initial velocity is 0. If something's coming to a stop, we know that its final velocity is 0. And then sometimes we'll have a problem where something gets batted back in the opposite direction. If that's the case, you know that directions, if something's moving to the right or to the east, that's a positive direction. If it's moving to the left or west or getting batted back in the opposite direction, we take that to be a negative. So make sure you get your signs right on these or you'll miss a lot of these problems. Now, another thing we talk about is law of conservation of momentum. That says that before a collision, the momentum total of two objects before a collision equals the total momentum of two objects after the collision. Even though their individual momentums might change, if you add them up, the momentums will be the same. And it says that momentum is not created or destroyed, it stays the same. It's not lost or gained. It stays the same, it's conserved. We talked about elastic collisions and inelastic collisions. Elastic is when objects do not stick together. So after the collision, they have different momentums. And also different final velocities. Inelastic collisions is where they stick together, the two objects that collide. And that means that after the collision, they would have the same final velocity. And the equations we use show that. So if we look at some problems, a few of these calculate the momentum of a 4 kilogram object traveling at a velocity of 12 meters per second east. Sometimes it will give you a direction east and you need to show out in your answer. Sometimes it won't and you don't have to worry about it. But we know that we're given a mass of 4 kilograms and traveling at 12 meters per second east. So I'm given a mass 4.0 kilograms. I'm given a velocity of 12.0 meters per second east. A mass is solved for momentum, which is P. Next, my equation. My equation is P for momentum is P equals M times V. Now let's plug those numbers in. The mass would be 4.0 times the velocity, which would be 12.0. So my momentum would be 48.0 kilograms times meters per second. Now, if I was having to solve for velocity in that problem, if I take my equation, if I solve for velocity, I would divide both sides by m, and my velocity would be momentum divided by mass. So we're just using algebra. Plug in your numbers and solve for your unknown. Okay, next. A 5 kilogram object has a momentum of 25 kilograms times meters per second west. What is its velocity? Well, I'm given a mass in the problem of 5.0 kilograms, and then it has a momentum 25.0 kilograms times meters per second, and then west. What is its velocity? I have my equation, P equals mv. Plug in my numbers. For P, it was 25.0 equals 5.0 times V. Divide both sides by 5.0. And then my velocity would be 5.0. And then that would be meters per second. And it'd be west since it gave me a direction. Okay, next problem. It says a .144 kilogram baseball is pitched horizontally at 38 meters per second. So I'm given a mass there, and I'm given a velocity, 38 meters per second. The batter hits a horizontal line drive at 38 meters per second in the opposite direction. What's the ball's change in momentum? Alright, so I'm given a mass, 0.144 kilograms. I'm given an initial velocity, it hits it, and it's going to be positive 38 meters per second. Then he hits it back in the opposite direction. The final velocity is going to be negative 38 meters per second because he hits it back in the opposite direction. What's the ball's change in momentum? My equation for the change in is delta P equals M VF minus VI. I plug in my numbers. Delta P is equal to my mass is 0.144. My final velocity is negative 38 minus my initial velocity is 38. And I'm going to bring up my calculator to solve for this. So negative 38 plus negative 30 would be negative 76, and then multiply that times 0.144. And now we get 10.94. So my delta P would equal negative 10.94. My units would be kilograms times meters per second. That's how you'd solve a problem on the change in momentum. Be careful about if something's in the opposite direction about the signs. Also, if it says something starts at rest, initial velocity will be 0. Something comes to a stop, the final velocity will be 0 in these types of problems. Okay, next. If I have a problem that says average net force of 25.0 newtons acts on the object for 2 seconds. What is the impulse of the object? So my equation for impulse, well, first the problem gives me a force, since it gives me something in newtons, 25.0 newtons. Acts on the object for a time period of 2 seconds. What's the impulse? In my equation, impulse is I equals F times T. And I just plug my numbers in. I is equal to 25.0 times 2, which would equal 50.0 newtons times seconds. Now I could have said 50.0 times kilograms times meters per second, since that's the same unit, but it doesn't matter. Okay, next it tells me that I have a 26.3 kilogram object is traveling at 21.0 meters per second. What average net force is required to bring this object to a stop in 2.6 seconds? So I'm given a mass, 26.3 kilograms, given a velocity of, that's my initial velocity, of 21.0 meters per second. What average net force is what I'm looking for, is required to bring this object to a stop. If it tells me about a stop, I need my final velocity's got to be 0. Then my time is 2.6 seconds. So my equation, the only equation I could use that has these things in there, and what I need is the impulse momentum equation. F times T equals M VF minus VI. I'm plugging my numbers, I'm solving for force. That's going to be force times my time, which is 2.6, equals 26.3. And VF is 0, so this is coming to a stop, minus VI, which is 21.0. So 26.3 times negative 21 gives me, so my force would be F times 2.6 equals negative 552.3. Divide both sides by 2.6. My answer is being 212. It's going to be negative though. Force is going to equal negative 212.42 newtons. And the reason it's negative is because it's coming to a stop. So the force is negative. It comes out negative. You could have showed your answer as positive. Nothing wrong with that. But there's nothing wrong with showing it, leaving it as negative also, just because that object's coming to a stop. Now our next problem is a collision problem. And when I have a collision problem, it says 1,000 kilogram car is traveling at 15.0 meters per second east, and a 2,000 kilogram truck is stopped at a traffic light. The two vehicles collide, and after the truck's velocity is 6.0 meters per second east, determine the car's final velocity. So it doesn't say anything about sticking together. This has to be an elastic collision, which means they're going to have different final velocities. I want to label what my first object is, what my second object is. I'm going to label the car, since this personally mentioned is my first object. The truck is going to be my second object. It always helps to draw a diagram of these of before the collision and after the collision. It helps you keep everything together. So before, let's say that this is my car, this is object 1. It's going to have a mass, it's got 1,000 kilograms, and it's going to have a speed. It's traveling at 15 meters per second east. Now, since it says east, it's positive. So this is going to be my M1. That's going to be my initial velocity for the first object, V1I. Next object is going to be M2. It's going to be a truck. And this car is moving this way. Now this truck is my second object. It weighs 2,000 kilograms. And it's stopped at a traffic light, so it is not moving. It's at rest, 0 meters per second. Remember, if something's moving to the left, it has a negative velocity. Always make sure in these problems that you do that. If something's moving to the left or west, you consider its velocity to be negative, otherwise you'll miss the problem. So that's before the collision. After the collision, it says the truck's velocity wants to determine the car is the first object still, and it weighs 1,000 kilograms. And it says, we don't know it, that's what we're looking for. So we're looking for V1F. It's our question mark. But afterwards, our truck, after it collides, it's moving east. It weighs 2,000 kilograms. And it says it's moving at 6.00 meters per second. And it's east, so it's positive. So I know that's going to be V2F, the second final velocity of the second object. And I'm looking for V1F in the problem. My equation is this one, M1 V1I. For an elastic collision, is M2 V2I equals M1 V1F plus M2 V2F. Now I noticed that my V2I, the initial velocity of the second object, is 0. So this whole thing here we can mark out. That's going to equal 0. Shortens our equation up. Now we plug in our numbers. M1 was 1,000 times the initial velocity, which is 15.0, equals M1. Again, M1 is 1,000. And we're looking for V1F. That's our unknown. Plus M2, which is 2,000, times V2F, which is 6.00. And we can shorten this up. That's going to become 15,000 equals 1,000 V1F plus 2 times 6. 2,000 times 6 is going to end up being 12,000. Now when we get to this point, we're going to subtract both sides by 12,000. That's going to equal 3,000 equals 1,000 V1F. Solve for V1F, I divide both sides by 1,000. V1F is 3,000 divided by 1,000, which is going to be 3. And then the units for velocities, meters per second. And it'll be positive, so it'll be moving to the right at 3 meters per second. So when we do elastic collisions, we're using the long form of this equation, this whole thing. A lot of times we can reduce it. If something's at rest, you know, it's going to make it shorten up some. And remember, if something's moving, it tells you something's moving to the left or west, we consider that velocity to be negative. You just have to keep up with what is what. That's why it's best to draw the pictures where you can keep up with what object you're talking about and what speed it's moving at, and the initial velocities and the final velocities. Okay, one last problem. It says a 2,200 kilogram car traveling at 30 meters per second collides with another 2,200 kilogram car that is at rest. The two bumpers lock and the cars move forward together. What is their final velocity? Well, this says they lock and they move forward together, so it's asking for their final velocity. So this is an inelastic collision. They're sticking together and they're going to have one final velocity. Now I'm going to label this first object my M1. my first mass. Second object is going to be M2. And I'm going to draw these pictures for before the collision. And my first object here has a mass of 2,200 kilograms, and it's traveling at 30 meters per second. It doesn't tell me the right or left, so I'm just going to assume it's to the right. And it's positive 30 meters per second. So I know this is my V1I. And then collides with another car that weighs the same amount. So my M2 is 2,200 kilograms. Its initial velocity is 0 meters per second because it's at rest. So I'm considering rest to be my V2I, the initial velocity of the second object. This is after the collision. These two objects are going to lock together and move off at the same final velocity. And I know that their masses, this is 2,200 and this is 2,200, and they're moving off with the same final velocity, which is what I'm looking for. Now this equation is a little bit different than the others, the right side of the equation anyway. So the equation is M1 V1I, it's the same on the left as the other equation. M2 V2I equals M1 plus M2 times VF. Now I'm plugging my numbers, and I realize that my V2I is 0, so it's going to make this whole thing equal 0. I'm shorting that up. Now M1 is 2,200 times V1I, which is 30, equals M1 plus M2, that's 2,200 plus 2,200 times VF. Now 2,200 times 30 is going to be 66,000 equals 2,200 plus 2,200 is 4,400 times VF. Divide both sides by 4,400, and VF is going to equal 15 meters per second. And that's how you work these problems. These are the types of problems that are going to be on the tests. There's no surprises. You know, make sure you do the study guide, and then you check your answers to make sure you get the right answers, and do the little practice quizzes that I put on there for a review, and you should be fine on this third nomics test.